We're back live here at Mount Wilson Observatory, 5,700 feet above Los Angeles and above Pasadena, California. It's a beautiful day today, a perfect day for the Venus transit. We're at a very historic location itself. Mount Wilson is the home of the world's biggest telescope twice, and the first of their kind a few times with the solar telescopes. We have one live feed that's coming from one of the solar telescopes there, actually a 150-foot long telescope tipped straight up. We've got a nice view out over the Los Angeles basin as well. And we're going to talk now with the director of Mount Wilson Observatory, Hal McAlister, who is welcoming all this crowd and everything here. Well, thanks very much, Hal. It's great to be up here with you.
Oh, it's my pleasure. It's a lovely day. The weather's great. The wind is mostly calm. It's cool and beautiful. The seeing is pretty good, and we're watching this gem of a thing happen but live before our eyes. So thanks for being here.
Well, it's been a lot of fun, and we've got a lot of things going on here because this is pretty much, for those who weren't going over to Asia or up to Hawaii, this was the place to be. You mentioned seeing, that's a technical term we astronomers use, and it's the steadiness of the air. And as people know watching the live feed, that's got to be really good. But Mount Wilson's known for that.
Mount Wilson has a reputation, even though it's above Los Angeles, where the skies have been brightened, of course, over the years. It was established in 1904 when LA was very, very dark. But as the years progressed, the skylights lit up. But it still remains a superb site for looking at relatively bright objects because of this good seeing. The cold air comes in across the Pacific. It's very stable. There's not a lot of turbulence, and it doesn't become turbulent and bumpy and distorting the air until it washes back behind the San Gabriels. So it's like the prow of a ship plowing through just beautiful, stable air. And we have projects here that just thrive upon that attribute.
Well, that's one of the important things in some of the top observatories in the world, such as the top of Hawaii at Mauna Kea. And in the Andes in Chile is not just that it's very dark, but also very, very steady air.
That's right. Darkness and good steady air are really what astronomers look for. And if you're interested in studying things that are at the edge of the universe and very faint galaxies, Mount Wilson is past its prime in that regard. But if you're interested in studying nearby phenomena associated with stars that aren't so terribly faint, it's still a superb site. It's often reputed to be the best continental site in the U.S.
And so I've talked about the history because I've actually been involved at Mount Wilson Observatory for 30 years. A little, truth in advertising here. This is not my first trip up here, and I've known Hal for a very long time. And my interest has always been the history as well. So, and you can see, in fact, behind us, we have a nice shot of solar telescopes. In fact, those two things that looked like water towers that somebody took a chunk out of are actually solar telescopes. They're pointed at the sun now. One of the views that you're getting, the one that shows kind of a wide shot, you can see people looking down at an image of the sun. That's coming from the taller tower. There are actually 3 solar telescopes in that view. And these are all 100 years old or more, but this is not what Mount Wilson is all about today. It's just the history, because in fact you built a really cutting-edge instrument up here, the biggest of its kind, really, in keeping with George Ellery Hale's tradition, that's doing fantastic research and making new discoveries.
Yeah, when Hale established this place, it was cutting-edge technology, just state-of-the-art. And although he's been gone many, many years, he would be pleased to know that in its second century, Mount Wilson is still home to something that's state-of-the-art and cutting-edge. And that's an optical interferometer called the CHAR array, which is owned and operated by Georgia State University, which is my real employer. And we built this here about 10 years ago, and it is the highest resolution telescope in the world, on the planet. We can see things here that you can't see from any other telescope.
Mm-hmm. Now people are going to say, well, wait a minute, there are bigger telescopes around. We know that, but how is it that this telescope, which is really a number of small telescopes, manages to see sharper detail than those things do? And of course, there's a trade-off with this.
There is indeed a trade-off. It's actually not a single telescope, but it's an array of 6 telescopes, each of which has a mirror 1 meter in diameter, 40 inches across, and they're spread out over the grounds of the observatory, contained inside a circle 200 meters in radius. Mm-hmm. And it actually acts like it's a big single 400-meter diameter mirror, but it's relatively dilutely sampled. That is, we don't catch all the light a true mirror like that would, but we catch the light from these 6. That's why we're limited to relatively bright objects. We can't go very faint. But because we're spread out over this large area, we mimic, from the purposes of seeing fine detail, a single enormous telescope that is incredible in size and unaffordable in anybody's budget if you tried to build a single telescope like that.
So what kind of detail can you see, and what sort of discoveries have been made that you can't do with these huge single telescopes?
It's the only telescope in the world that can look at other stars like the sun. And we have telescopes that can resolve supergiant stars, which are enormous compared to the sun. But we have large enough synthesized aperture. We kind of fake it by making it big. We can zoom in and we can look at stars the sun size and smaller, but we're not looking at just every Joe Blow star. We're looking at stars that are interesting. For example, some stars rotate so rapidly, they swell out at their equators and they shrink in at their poles. And so you see this oblate shape, and we're measuring those, and that has features on the surface that you see only on stars like that. We're looking at close binary stars that have periods of a few days, and they're zooming around each other, and they actually are distorting each other's shapes and exchanging matter. One very famous star that many people know is the star Algol, and we recently have resolved it, and we have a nice movie of the inner Algol system going around and going through eclipse. So those are the kinds of things we specialize in.
And Algol is a type of binary star, which means two stars orbiting around each other, which is really more common than our single star, the sun, having multiple star systems. And it's one that's known to observers, naked eye observers, back through the centuries, back through the millennia, because it occasionally dims its light. And that's because one star is going in front of the other one. And that's the kind of thing you get a lot of information from, and not too different from the things we've been talking about today with exoplanet transits and so on, that the transit of Venus is an analog for.
Right, yeah, that's correct, yeah.
So what about the future of Mount Wilson Observatory now?
Well, we're in our second century, well into it, and Mount Wilson has this interesting juxtaposition of the new cutting-edge facilities up here with the old magnificent instruments from which modern astronomy was born. And so I think its future lies in still being a very viable and important astronomical research site, but preserving the 100-inch telescope and the solar towers and the 60-inch, because these were truly remarkable instruments from their engineering point of view and also from the fantastic science and really launching of modern astrophysics that occurred here. So this really is a kind of a world treasure of astronomical and scientific heritage, but still has a great viability to do modern astronomy. I mean, one other thing I'd point out is that the 150-foot tower behind us, just Thursday of last week, was the centennial 100th anniversary of the first sunspot drawing ever made there. And they've been continued every clear day. There was one, I'm sure, made this morning. So that work continues on. So it's, there's no stopping this place.
Mm-hmm. Absolutely. And I don't know if we can see it in the shot there, but to the right of the solar telescopes, the tower telescopes a little bit, you can see it looks like an old galvanized sheet metal building there. And that one is actually the first solar telescope here from 1904. I know that one well because I operate that one. One of the few people still here that are able to use that.
We use it. Care of you, so
that's right. The knowledge passes on with me. Yeah. But you've got some others. And that one, of course, is a very historic telescope, and we have the joy of using that for educational programs here at Mount Wilson. And we have a video that is really wonderful, says something about the history and the current, and also talks to some of the students we have at that we have in this educational program.
That's right, yes.
Yeah.
Yeah, there's a program called CURIA, which is a consortium for undergraduate research and education in astronomy. And they have a wonderful program that Mike has been instrumental in over the years, and it's coming up in a few months, in fact.
A few weeks, I'm afraid.
Okay,
yeah, I'll
right
be
around
back
the corner.
up here for a couple of weeks. Yeah. So it's early this year. It moves around. So, Hal, if you have anything else you want to add before we go to to our video about Mount Wilson.
Well, I appreciate the interest. Mount Wilson, I think it's true that this is the first transit ever observed by humans from here, and it will be the last one for an awfully long time. And it's wonderful that this historic event to this day is being observed from this very historic place. So thanks for being here.
I have to believe, and I really expect it's true, that this observatory will be functioning in 105 years when the next transit takes place.
Let's count on that.
Yes, and we're going to go to this video now, and I want to just mention, too, for those of you watching from Southern California here, there is a docent program, and there are people who come up here and share, as volunteers, share the knowledge and the real joy and treasure of this observatory. I've toured thousands of people through this observatory, and everyone is blown away by it. So they have the opportunity to be a part of that if they want to as well.
Just Google Mount Wilson Observatory and get our website, and you'll find out all about it.
Yeah, or if you can remember, mtwilson.edu.
Exactly.
So we'll be back after we take a close-up look here at the Mount Wilson Observatory through this trailer.
The Mount Wilson Observatory, founded in 1904, is where the real stars of Los Angeles have been studied for over 100 years, where some of the greatest discoveries since Galileo and Copernicus were made. And it's largely because of George Ellery Hale, a determined solar astronomer from Chicago, who decided that Southern California was the perfect place to unravel the secrets of the stars.
Hale, of course, made the deliberate decision that the atmospherics of Southern California were the best in the world. But of course, he was coming into a culture in which nothing like this had ever been done before. The sheer boldness of constructing an observatory atop a then very remote and underdeveloped mountaintop would be quite a challenge.
Nearly everyone told Hale that he was wasting his time and other people's money. One of the leading astronomers of the day, Simon Newcomb, was more clear on the subject.
We are probably nearing the limit of all we can know about astronomy.
But Hale was sure that a new era of exploration was at hand. He likened his new astronomy to one of the greatest treasure hunts of all time. After an exhausting battle with Andrew Carnegie, Hale persuaded him to invest a considerable sum in the new science of breaking apart the sunlight into its rainbow of colors. Our sun, as Hale constantly pointed out, was the nearest star. He felt that if he could tease more secrets out of our sun, the secrets of the entire universe might follow. Within a few short years, Mount Wilson's solar telescopes were producing the best images anyone had ever seen.
The sun revealed more about how stars behave by many orders of magnitude than any other star.
But little else was known about our nearest star.
We didn't know at that time whether the sun had a magnetic field. We didn't know about the sun's chemical composition. What was it made of? We had no idea about the energy generation, what actually powered the sun. There are just a number of outstanding questions.
In 1908, with Carnegie's help once again, a new telescope was completed to study the heavens at night above Mount Wilson. The 60-inch telescope was the biggest telescope in the world, and soon enough made a momentous discovery. It was determined that our sun was not at the center of the Milky Way, but at a remote outpost of the galaxy, a revelation which made headlines around the world. Almost immediately, Hale began work on a telescope 100 inches in diameter. It would be a monster, weighing 100 tons. Once again, the doubters weighed in, pointing out that a telescope 100 inches in diameter might not work, and in any case was probably unnecessary. Most thought the universe couldn't possibly be bigger than the Milky Way. In 1917, after 10 years of work, partly delayed by World War I, the 100-inch telescope dome was completed on Mount Wilson. It had been a heroic effort to bring all the supplies up a narrow trail, sometimes by mule, to make the most precise and complex scientific instrument ever made. An elaborate gravity-driven clock drive, weighing several tons, would guide the machine across the sky. The telescope resembled a 100-ton Swiss watch. The new mirror for the telescope, nearly 9 feet across and polished to within 2/millionths of an inch, was slowly and very carefully taken up the mountain. Reporters covered the entire 9-mile journey. Creating the giant mirror had proved an almost impossible task, and the initial focusing was difficult. But finally, Mount Wilson's newest machine was ready for its voyage.
6,000 feet up with Mount Wilson Observatory below, the scientific eye of America. To this mecca of stargazers flock astronomers from all nations. Here we are behind the scenes. Great changes are occurring throughout the universe. The observatory's 100-inch telescope, largest in the world, is daily...
Mount Wilson astronomers would soon become some of the world's most famous scientists. They published dazzling photographs of the moon, showing lunar mountains 20,000 feet high. Stars were measured that were 300 times bigger than the sun. Hale told his nephew that it was like a dream, like something from Jules Verne.
The effect in the big dome is striking enough. The huge telescope, half visible in the moonlight, pointing up through the shutter opening, looking down into the craters. I cannot feel envious of anyone under present conditions.
A young astronomer named Edwin Hubble took the reins of the giant new machine and within a short time made a discovery that shook the foundations of astronomy. It seemed that the Andromeda Nebula was not in the Milky Way at all. If so, this had tremendous implications.
This object was not in the Milky Way, but it was probably 40 or 50 times further away than the extent of the known Milky Way, so it was an object unto itself.
The size of the universe from Mount Wilson had grown almost beyond imagination. Searching for new worlds could be extremely demanding, particularly as the cold of winter enveloped the mountain. But the excitement of discovery helped astronomers endure photographic exposures that could take several nights to complete, while they remained nearly motionless as the machine explored the heavens. With each passing year, the discoveries continued. In 1929, Edwin Hubble gathered critical evidence with the 100-inch telescope to confirm the idea that the universe was not only vastly bigger than the Milky Way, but that it was expanding. It seemed that the farther away the galaxies were, the faster they were moving away from the Earth.
His discovery of expansion suddenly opened this new discovery that the universe is evolving. It's moving. It's changing with time. And what Einstein realized was that the universe would have to either be contracting or expanding, but it wouldn't be stable if it was a static universe. Einstein was later quoted as having said that it was his biggest blunder because he missed the opportunity to predict the expansion. Well, this must have been astounding for Hale to have had literally one of the most revolutionary discoveries since the time of Copernicus, discovered with the telescopes he enabled.
Record numbers of the public wanted to see the fantastic machines on Hale's Mountain and share in the excitement of the new discoveries, which almost always brought more questions than answers. Hale met with Einstein to discuss why the universe seemed to be exploding. The findings of an expanding universe would lead directly to our current idea of cosmic origin, which is known as the Big Bang Theory. When George Ellery Hale died in 1938, newspapers around the world ran stories of his accomplishments. The New York Times called George Ellery Hale the priest of the sun. Another called him the greatest modern astronomer.
His legacy, I think, has been unsurpassed in terms of what he set in motion and what he was able to achieve in establishing telescopes at Yerkes, Mount Wilson, the solar telescopes, the 60-inch, the 100-inch, the 200-inch, the establishment of Caltech. That was his brainchild, the Astrophysical Journal, the National Research Council. It's an astounding list of things. It's an astounding story.
We have to see the Mount Wilson Observatory, not just a contribution to great science, which it was, not just a contribution to the rise of Pasadena as a great university city, which it was, but also as an engine of economic development. After all, it establishes a DNA code for Southern California, centered in Pasadena, which then yields over time the Jet Propulsion Laboratory, which in effect creates a whole web of scientific and high-tech industries today that if you start collapsing them back to their origins, what do you find? You find that astronomical dome atop Mount Wilson.
There are now bigger telescopes in the world, but few offer the chance to touch the history of human exploration like those on Mount Wilson. Today, in spite of the ever-present lights of Los Angeles, new discoveries are being made at the observatory. The location is still considered one of the best in the world, above the inversion layer of the city, and in the smoothness of the ocean air coming in from the Pacific. New telescopes have been set up to study the physical properties of stars, including the biggest interferometry array in the world, known as CHARA. CHARA is an array of 6 telescopes, like this one, from which the light is ingeniously combined, giving it far greater resolution than the Hubble Space Telescope. The array recently made the first image ever of the surface of another sun-like star, measured distorted stars, and even determined the size of a planet orbiting another star. Nearly every weekend, tours are given to the public and to school children. An increasing number of volunteers teach children about this remarkable history and show them Mount Wilson's amazing machines, which are still in operation, scanning the skies in new ways. The famous 100-inch telescope, which discovered the wider universe, is now assisted with computer-driven adaptive optics, giving it even greater power. The 60-inch telescope is now accessible to individuals and groups, allowing them to see with their own eyes brilliant star clusters and distant galaxies through the very telescope that a century ago charted our true place in the Milky Way. Mount Wilson is also busy with ongoing solar studies at Hale's original solar towers, including the 60-foot and 150-foot towers. There are also invaluable education programs that are conducted for undergraduate astronomy students.
We take tours of all of the facilities here, all the telescopes, and we see pictures, and it's like Einstein stood right here. Hubble's expansion of the universe was discovered right here. I think that is what is the coolest part about this program.
This is live physics. This is hands-on. This is raw data. This is not from the textbook. This is how it started. This is how it was first discovered, and we're rediscovering it.
Actually being able to do the observing, see the instruments, take the data, see what you can get from it. I think that's the most exciting part about it, and seeing that, wow, I'm actually here. I'm actually doing what astronomers do.
Ambitious plans are currently underway for a new golden era at Mount Wilson, including restoration of the original facilities, expanded scientific use of the 100-inch telescope, construction of a modern visitors center, and expanded public access and special education and outreach programs aimed at reawakening our nation's youth to the rewards of scientific exploration. 100 years ago, George Ellery Hale captivated the public as he spoke about the heavens.
Like buried treasures, the outposts of the universe have beckoned the adventurous from immemorial times.
Perhaps it's because in the process of looking to the heavens, we as a species continually rediscover ourselves. Now a new generation will explore the universe in their own imagination from this treasure of American science, the Mount Wilson Observatory.